Question number 21. The following data was obtained when dinitrogen and dioxygen react together to form various compounds. So mass of dinitrogen is given, mass of dioxygen is given, and we are asked as to which law of chemical combination is obeyed by the experimental data. And also there's another question as to we have to give the statement. So first of all, we will fix the mass of dinitrogen as 14. So if we fix the mass of dinitrogen as 14, the mass of dioxygen becomes 16 grams. Next, 32 grams. Because it's 28, 14 divided by 2, so 32 divided by 2, that becomes 16 grams, and then 80 also gets divided by 2, that becomes 40 grams. So if I take a ratio of all of these, 16 is to 32 is to 16 is to 40, this is equal to 2 is to 4 is to 2 is to 5. So this is nothing but the law of multiple proportions. So this states that when two elements combine to form two or more than two compounds, then the mass of one of the elements which combines with the fixed mass of the other element is of a simple whole number is a simple whole number ratio. So we had already done a detailed explanation about the law of the various laws of chemical combination. One of them is law of multiple proportion. Question number 21b. We need to fill in the blanks for the following conversions, and we'll be doing this by the unit conversion method. So let's take the first one. We have to convert 1 kilometer is equal to how many millimeters, which is equal to how many picometers. So first of all, 1 kilometer equals to 1000 meters. 1 meter equals to 100 centimeters, and 1 centimeter equals to 10 millimeters. So the unit conversion factors will be 1000 meters by 1 kilometer, 100 centimeters divided by 100 centimeters divided by 1 meter, and 10 millimeters divided by 1 centimeter. So by the rules of unit conversion factor, 1 kilometer will be equal to 1 kilometer into 1000 meters divided by 1 kilometer into 100 centimeters divided by 1 meter into 10 millimeters divided by 1 centimeter. So based on the rules of unit conversion method, kilometer gets cancelled, meter gets cancelled, centimeter gets cancelled, giving us millimeter. That's up to 1, 2, 3, 4, 5, 6. There are 6 zeros. So 10 to the power 6 millimeter. So 1 kilometer is equal to 10 to the power 6 millimeter. Next, we need to convert 1 kilometer to 1 picometer. So 1 kilometer to 1 picometer. This conversion is done by 1 kilometer. Again, similar to previous one. I'll write it here. 1 kilometer equals to 1000 meters. Okay, and 1 picometer equals to 10 to the power minus 12 meters. So the unit conversion factors are 1000 meters divided by 1 kilometer and 1 picometer divided by 10 to the power minus 12 meters. So we'll just substitute similar to the last time. 1 kilometer equals to 1 kilometer into 1000 meters by 1 kilometer into 1 picometer divided by 10 to the power minus 12 meters. So kilometer gets cancelled, meter gets cancelled, leaving behind only picometer. So that's equal to 10 to the power 15 picometer, because this 12 comes to the top, so it becomes 10 to the power 12. 12, 13, 14, 15. So 10 to the power 15. So here you have 10 to the power 6 and 10 to the power 15 picometers. Next one, we have to, let me just erase this. Okay. So we need to convert 1 milligram equals to how many kilogram equals to how many nanograms. Okay, so 1 gram equals to 1000 milligram. Okay, and 1 kilogram equals to 1000 gram. So the unit conversion factors are 1 gram divided by 1000 milligram, because here we want milligram and milligram to be cancelled, and 1 equals to, since we want grams to be cancelled, 1 kilogram, and we want kilogram in the numerator, so 1 kilogram divided by 1000 grams. So similar to the last time, 1 milligram equals to 1 milligram into 1 gram by 1000 milligrams into 1 kilogram by 1000 grams. So here you have milligram being cancelled, gram and gram cancelled, leaving behind kilogram. So that's, so these these 2000 values are on the numerator, thereby the value of this equals to 10 to the power minus 6 kilograms. So here you have 10 to the power minus 6. I'll just write it here as well. The next one is we need to convert it to nanogram. So we need to convert milligram to nanograms. How shall we do that? This will be again by the unit conversion method. So here also you have 1 milligram, 1 gram equal to 1000 milligram, and 1 nanogram equals to 10 to the power minus 9 grams. Okay, so 1 will be equal to, since we have milligram in the numerator, we want it on the denominator. 1 gram divided by 1000 milligram, and since you have the gram on the numerator, we want this on the denominator, which means 1 nanogram, and we want nanogram on the numerator because we want the answer in nanograms. So 10 to the power minus 9 grams. So 1 milligram will be equal to 1 mg into 1 gram divided by 1000 milligram into 1 nanogram by 10 to the power minus 9 gram. So we will be cancelling the units. So you have milligram and milligram cancel, gram and gram will be cancelled, and you have to simplify the values, and you get the answer as 10 to the power 6. So 1 milligram is 10 to the power minus 6 grams and 10 to the power 6 nanograms. The last one, we are converting milliliters to liter. That should be a straightforward one. So let's do it. I'm just going to leave it at this because it's to top. So 1 milliliter is how many liters? So 1 ml equals to, sorry, 1 liter equals to 1000 ml. So our unit conversion factor, because ml is in the numerator, you will want it to be on the denominator. So 1 equals to 1 liter divided by 1000 ml. So we have to substitute 1 ml equals to 1 ml into 1 liter divided by 1000 ml. ml and ml gets cancelled, and so we get 10 to the power minus 3 liters. So here 1 ml is 10 to the power minus 3 liters. Next we need to convert it to decimeter cube. Now first of all, 1 ml, you can't just convert the units of length directly to volume. So 1 ml equals to 1 centimeter cube. Okay, so 1 centimeter cube is equal to, or rather 1 second, 1 decimeter equal to 10 centimeter. Now we have it in cube. So 1 decimeter cube will be 10 to the power 3 centimeter cube. So 1 ml will be equal to 1 centimeter cube into, the unit conversion factor over here would be 1 equal to 1 decimeter cube divided by 10 to the power 3 centimeter cube. So 1 decimeter cube divided by 10 to the power 3 centimeter cube. And so here also you will be cancelling the centimeter cube and this one. So this gives us a value of 10 to the power minus 3 decimeter cube. Okay, so 1 ml equals to 10 to the power minus 3 liters, and that's equal to 10 to the power minus 3 decimeter cube. Question number 22. If speed of light is 3.0 into 10 to the power 8 meters per second, calculate the distance covered by light in 2.00 nanoseconds. So we've been given the speed, and that's 3.0 into 10 to the power 8 meters per second, and we have been given time. We have to calculate distance actually. Time as 2.00 nanosecond, and from this it's obvious that we need to convert this nanoseconds into seconds, and that's done by multiple. Basically 1 nanosecond will be equal to 10 to the power minus 9 seconds. So the unit conversion factor would be 10 to the power minus 9 seconds divided by 1 nanoseconds. So 2.00 nanosecond into 10 to the power minus 9 divided by 1 nanosecond. And so these two values will get cancelled, and you get 2.00 into 10 to the power minus 9 seconds. Okay, so we know speed equals to distance by time. So distance will be equal to speed into time. So that's 3.0 into 10 to the power 8 meters per second into 2.00 into 10 to the power minus 9 second. So here the second inverse and second will get cancelled, leaving behind meters, which is the unit for distance. So 3 times equals to 6. So this gives us 6.00 into 10 to the power minus 1 meters, or 0.600 meters. So we just had to convert the nanoseconds to seconds, and that was done by multiplying it with 10 to the power minus 9. And then distance equals to speed into time.